Areas for future work. As I said, my simulation's just a prototype right now. Make it more robust. Perhaps utilize remote resources. You can use grid computing, say. You can easily break up these large, linear algebra operations that you do in the simulation across the grid. I could look in, or anyone else, look into the QRAM model. And that's essentially how the quantum and classical computers interact. Everyone's kind of said, okay, we have your classical computer, let's control. The quantum computer is a slave. And then you send operations to the quantum computer and get back a result. But really, how's that interaction work? What happens when you start sharing quantum resources? What happens, when the client times out, when the master times out, and so on and so on. So there's a lot of work there. Obviously, I can provide solutions to other quantum algorithms, such as the unsorted search. And perhaps the most obvious area is the number of quantum algorithms is still pretty small, really a couple, handful or two of cases. So there could be a lot more work going into the development of algorithms in general. But I think part of the problem with that is kind of grasping your head around how a quantum computer works and kind of exploiting that to solve a problem better than you can classically. So in summary, you can do things with quantum computers that you can't do on classical computers, no matter how fast they become. For some problems, once you start scaling up, you could exploit every atom in the universe to compute for you, as a switch say, and you still wouldn't be able to solve the problem. Obviously, existing quantum programming techniques, suffer from numerous flaws, the usability ones, and just being very, physics, mathematic oriented. And Cove is what I've developed is a new method of programming quantum computers where I've tried to avoid those flaws and really kind of leverage what's already there classically to only tackle quantum computation. And that pretty much sums things up. I've got a website where I have all the source, documentation, and so on posted. I've kind of tried to adopt a Science 2.0 approach, is what some people call it. So my source is checked into a source code management system, so you can see how things have evolved as I've worked on them. I also have a blog on there. I really haven't been updating, but kind of contains in a more kind of informal form some of my rationale behind things and problems I ran into. So, are there any questions?
This is not directly related to what you've done, but could you speculate on architectures or biological systems or quantum implementations?
Not a whole lot. I specifically tried to kind of avoid that area and kind of focus on using the idealized quantum computer that behaved according to all the math. People talk about using the spin of an electron to compute also the orientation of photons, but at this point really there's a couple different possibilities that are all being looked at. So as far as what actually ends up evolving, I couldn't really give you a good guess.
But in all these technologies, they're destructive reads, right?
Correct. Once you read it,
right,
it collapses it down to a single result, and you can't recover or ever know what the
So the
state
cat's
was.
either dead or alive until you open the box.
Exactly.
Exactly. And then you know. Yeah, exactly. Any other questions, comments?
There's got to be more questions, otherwise you'd have to redo it. So we have
I don't say that.
So, just a general question, Matt. What was the toughest operation, number of function you had to do?
I think it really goes back to those two. I kind of touched on but just reordering the operations and expanding them. It's easy to say, you have 2 qubits. Here's a C0. You apply it. The math, simple, straightforward. But it's really I have an operation that operates on 3 qubits, but I have a register of 7, and I want to target this, that, and this.
Right.
And the math and just getting it to work correctly. I built up my own complex number class and complex matrix class to handle this. So that was just a lot of kind of plumbing I needed to do just to begin with.
You said that there was a lot of digging involved in finding